Almost ready. Everybody's ready. Take another half minute if you're still banging on your calculator. All right. If you got a number larger than 100, raise your hand. Larger than 200. Larger than 300. Larger than 400. Get about 340 something? Excellent. Okay, now the molar mass is a tool. It's a tool we're going to use in conversions, which is really the meat and potatoes of where we are. We need to be able to convert between moles and grams, and now we have the tool to do it. And what we're going to be using is something I like to call a T-chart. We're going to do mole to mass conversions. We're going to convert between grams and moles. Instead of always having 1 mole of something, we're going to figure out how many grams is it when you have 3/4 of a mole, or so on. So we're going to use a tool, and let me explain how this tool works. The first thing you do to make this tool, we're going to call it a T-chart, is you make a T. Just like that. Or a cross with a long edge. Or a cross with a short edge. Or a sword. Sword. Make a sword chart? Okay, so we can make a sword chart. There we go, now it's a sword chart. In our T chart or our sword chart, we're going to write what we start with up here. This will be our starting box. And there will always be 3 things in each box. Every box is going to have 3 things. What's going to be those 3 things? You're going to have a number, you're going to have a unit, and you're going to have a chemical. Every box is going to have those 3 things.
Wait, every box?
Every box, each box will have those 3 things. Each box, except for the one below our starting box. The starting box gets a squiggle because nothing goes down there. Nothing goes in that box. Okay. And what's going to go here is our molar mass. Molar mass is going to go in that box, or those 2 boxes. And we're just going to practice this for the rest of the day until we are mole mass conversion masters. Okay. So here's our first example. Just walk through it with me. Here we go. Sodium has a molar mass of 23 grams per mole. Hey, we didn't have to look at the periodic table. It told us what it is. How many moles do you have in 115 grams? So the first thing we're going to do is we're going to make our T-chart. And we're going to write down our starting unit. Give us a squiggle because nothing goes right there. We're going to write down our starting unit. Now here's the important thing. The starting unit will never have 2 units. It would never be gram per mole. It'll always be just one thing. In this case, it is what? Grams. So our starting 3 is 115 grams of sodium. 115 for the number, gram for the unit, sodium for the chemical. I wrote that kind of small. Can you see that in the back? Yes. Okay. People in the front row are saying yeah. Yes, they can. I'm sure they can. Okay. So we've written down our starting 3. Now here's the crux of the T-chart method. You bring down your unit and your label. So you're going to bring down your grams of sodium, and that's going to go to the bottom box down there. And in the top box is going to be the other thing. So if grams is down below, what's going to be up top? The mole. The mole of sodium is going to be up top. If grams is down below, then mole has to be on top. Now if mole was down below, gram would be on top. If we started with moles, then mole would be on the bottom and gram would be on top. But since we started with grams, gram is on the bottom and mole is on the top. Okay. Give me a thumbs up if you understand what we did so far. Let me gauge understanding. Looks pretty good. Okay, great. Next, we need to write in our molar mass, and it tells us what the molar mass is. The molar mass is 23 gram per mole. Now, you're driving down the road, you look at your speedometer, it says 65 miles per hour. Is that 65 miles per how many hours? Or is it 65 miles per 1 hour? It's always per 1. Similarly, molar mass is always number of grams per 1 mole. So the mole up here is going to get what line? A 1. It's going to get a 1. And down here we're going to write 23. This is the molar mass. 23 gram per mole. But Mr. Bars, you wrote your fraction upside down. I know, which you can totally do because it's not a fraction, it's a conversion. The molar mass is not a fraction, it's a conversion. So if I went to the donut shop and I asked for 12 donuts, how many are they going to give me? 12. Yeah, and they're going to call it a dozen. Or if I go in and I'd like a dozen, how many are they going to give me? 12, and I'm going to call it a dozen. Okay, they're conversions, they're the same thing. They're not fractions. So, here's my favorite part. Don't you love it, guys? Don't you love it in math where you get to cross stuff out? Like you have an equation that says y equals 3x squared over 2x, and you get to cross things out? Yeah, everybody loves crossing stuff out. You're like, all right, I'm going to kill that x, and hey, we simplified it. Love that. Okay. Would it be easier if I just did y equals 2x over x, and then you just cross out the x's?
There you go. You got it now.
Well, anyway, so once you've got this down, you can cross out the unit you don't want. Grams of sodium is on top and grams of sodium is on the bottom, so you get to cross them out. And you're left with your goal unit, the unit your exercise is looking for.
Would you do inverse operations?
No. I'm glad you mentioned that, though.
Oh wait, not inverse, cross multiply.
No. And I'm glad you mentioned that. Do not cross multiply. You divide. Yes, it is. So you divide. Do not cross multiply. I know it's going to feel like you should. Please do not cross multiply. Okay? These are not ratios. Okay? This is a mathematical function. Divide the top by the bottom. Do not cross multiply.
So, you know how we crossed out that other box?
Uh-huh.
Why don't you just move the 23 there and then you have to cross out a box? Yeah.
I don't know what you mean.
Because you already divided the 115 by this one.
Oh, why didn't I put the 23 right here?
Yeah.
Because this is the conversion. 1 mole is 23 grams. Our starting unit has no conversion. And this is a good segue to the next thing I have to say. Okay, guys? I realize a lot of your teachers are stupid. We're all stupid at some point. And sometimes you find shortcuts that work better, especially in math class. Here's the thing. There are definitely shortcuts in chemistry conversions. But realize if you learn this system, this is what you're doing today. This is what you're doing next week. And this is what you're doing in December. Okay? But here's the great thing. When you learned how to ride a bike, did you learn only how to ride a bike for 1 block?
Yeah, I learned how to ride.
No. Once you learn how to ride a bike, you're not limited by your distance, right? You could be like, I could do a mile. Yeah. Well, once you learn the system, if this is easy today, this will be easy in December. Okay? But if you don't learn this is going to give you fits. Does that make sense?
Yes.
So there are definitely shortcuts, and I accept that there are. You're going to find them online. There are shortcuts to doing simple conversions. But if you don't master the T-chart now, December is going to hate you. Okay. So, are we ready to move on?
Yeah.
So again, we divide 115 by 23, and we find that the answer is let's pretend that's a 5.0 moles of sodium. Yes?
So would the 5 basically be what that in this Google box, is that kind of what that would represent?
Actually, yeah. It would mean that 115 grams is 5 moles. Yeah. Okay, next. Actually, before we go on, I want a thumbs up that you understand what we're doing. Excellent. Everyone but people who are looking on their phone know what we're doing. All right, so how many grams are equal to 3.5 moles of calcium chloride? So again, make our T-chart. Now we're doing a little bit different, where we're actually starting with 3.5 moles of calcium chloride. We're starting with moles this time. So I've written my T-chart, I've written down my starting 3. What's my next step? Exactly, move down my unit, mole, and my chemical calcium chloride. And if that is moles, what goes on top? Grams. Grams of calcium chloride. Mr. Bars, I don't want to write those other 3 things. Again, trust me, if you're writing all 3 things in each box, it will take you an extra 1.5 seconds per box. But if you master this, this becomes very easy. If you don't master this, you'll be one of those people who are like, I hate stoichiometry. That's what it's called. That's what this is called. Stoichiometry. Yeah, go find one of your peers who's finished chemistry and say, stoichiometry, and they'll be like, ah, and they'll pee themselves. Because they hate stoichiometry. Okay, so guys, I'm sorry to make you laugh, but if this is grams and this is moles, where does the 1 go? With the moles. And looking at your previous exercise, go up 3 inches. What is the grams of calcium chloride per mole? 111? All right. So, again, now you've got your numbers on top, which is cool. So what do you get to do? Multiply. So you just multiply 3.5 by 111, and you get that many grams of calcium chloride. Oh, you want me to cross? You're right. I should cross out the unit. Bye-bye, moles calcium chloride.
Mr. Fox.
Yes.
Is the moles? Is it always 1?
It is always 1 in September.
Okay.
We're going to learn. Oh, it's always 1 when we're looking at gram per mole. Gram per mole will always be 1, always be 1, always be 1. But in December, we're going to learn something called the mole ratio, where we're changing chemicals. And when we change chemicals, then it will no longer be, that part won't be 1. It'll be like 1 to 2, 3 to 4, 3 to 2, 1 to 4. But when it's gram per mole, it's always going to be 1. Excellent question. So we can do this? We can do this math? You got something in the neighborhood of 380 something? Yeah.
88.5.
All right, cool. Again, 388.5, 389, 390. I'm fine with all those numbers. What is the mass of 0.46 moles of silicon dioxide? So see if you can put this in yourself. So take it from the top, put it in a T-chart, put it together, find the molar mass of silicon dioxide, and I will watch you. Excuse me. Okay, how to find the molar mass? All right, so moles is always going to be 1 because it's going to be grams per mole, like miles per hour, grams per mole. Yep. So mole will always be 1. And then, so SiO2 is 1 silicon. So as a look, do a side math. So 1 silicon and 2 oxygens. So write down the mass of a silicon. I like to write the whole thing out and then put the numbers right below it. So put the mass of the silicon under the silicon. So SiO2 is 1 silicon and 2 oxygens. So I like to write out SiO2, write the 20, well, write that number under the silicon, and then under the O2, write that number plus 2. I'm sorry, times 2. Then add them together.
32.
Yep. Then add them together. So you have the weight of a silicon and the weight of 2 oxygens, and you add them together, that will be the molar mass of the whole molecule. 60 sounds great. No, that is our starting unit. That's not molar mass. That's our starting unit. So our starting unit is moles of silicon dioxide. But our molar mass is going to allow us to convert that to grams.
Wait, so I put the starting right here,
Mm-hmm.
and then I put that right there?
Mm-hmm. Yep.
But it's supposed to divide.
And no, in this case, it's going to multiply. Because moles is up top and moles is going to come down below. So our units are going to come down, and our 60 is going to go in the top box. Then we're going to multiply across. Sometimes we multiply, sometimes we divide, depending on what we're looking for. Anyone else having a little trouble getting started? Anyone else have a pickle? Oh, a cucumber, okay. Guys, we have 7 minutes left. I'd like to do one more if we could. What did you get for the molar mass of silicon dioxide? 60? And then you crossed out your moles of silicon dioxide? And you multiplied across? What is 0.46 times 60? 27, and the unit is 0.6? 0.6 and grams silicon dioxide. Mr. Byers, is the unit important? Yes, the unit is important. Okay, so I'm hearing some chatter, and the thing I'm hearing a lot is, how did I get 60? Okay, so the molar mass is based on the periodic table, so we write our formula down, SiO2. Silicon, when I look at the periodic table, I see 28 for silicon. And then oxygen is 16, and there are 2 of them. 16 by 2. So I'm adding my 28 to my 32, and that's how I got my 60. Is this clear?
Yeah.
Question?
Do you always have to write like the grams and then CAC? That's how you're.
Yeah, again, I know it feels like it's a lot of extra work, but take the extra couple seconds for 2 reasons. 1, you can see when your units cancel out. And 2, if you go off the rails, I can see your work. If I just see a bunch of numbers, I'm like, I have no idea what these numbers represent. If you write your units, I'm like, oh, this is mole of silicon dioxide. It should be grams. Then I can help you. Yeah. Dustin?
Wouldn't it be grams over SiO2?
Grams SiO2 over mole SiO2?
Like the 27.6, the last one.
Oh, you want me to write it that way? I can totally write it that way. Yeah, I actually like to write it that way. It doesn't really matter. It's grams of, it's like pounds of spaghetti. So grams of SiO2, it's just a unit. But I like to write it that way because it fits in the box better. But yeah, you're right. Okay, so next one. I'd like to do one more the remaining 5 minutes. We have tons of labs, but in order to do the labs next week, we now know what we're doing. So I'd like you to do this one all on your own. And when you got your answer, I'm going to turn the lights on. When you got your answer, show your neighbor. And please show all the steps so you can compare your work with your neighbor.